Now, unfortunately, not all bugs result in nice assertion violation messages, and bug disambiguation can be trickier when all we have is something like a core dump or a stack trace. And so what these things are going to give is, at least if we have good debugging symbols, probably some sort of an indication of what part of the code failed, and then it's going to give an indication of the stack frames leading up to the failure. And so sometimes these are going to be useful for doing disambiguation and sometimes not. They provide kind of qualitatively at some level similar information to assertion violation messages, and if they're giving us some clues relating the symptom to the source code, but it's not going to be as easy to find, and it's not going to be as readable. Now, a third weapon we have in the arsenal when doing bug triage is actually pretty interesting, which is that we can do a search over the revision history of the software under test. That is to say, of course, if we have access to the revision control system, we can do this. So let's go back to our example here, where we have all these bugs. And so if it's the case that all of these bugs here appeared just one revision back, and these other ones appeared in different revisions, maybe weeks or months ago, then it's a good bet that all of these new inputs are triggering the same error. That is to say, an error that somebody just committed the other day. And these probably trigger older bugs. So this is a pretty powerful weapon. And some automated tools for revision control even build in functionality to do this search over version history. So for example, Git has a git bisect command that can be used to do a binary search over version history in an automated way. And even if that kind of thing isn't available, it's not too hard to script this up yourself, given an automated way to detect if a particular version has a particular bug. Now, our last way we can triage bugs is to examine the test case. And often it's the case that test cases that trigger the same bugs have similar features. So in the compiler bug finding example that I've been using, it's often the case that I'll look at a bunch of failure triggering programs, that is to say, inputs to the compiler that cause it to crash or otherwise fail, and they'll contain some sort of a smoking gun, like maybe 64-bit integer divides or something like that. So there'll be some sort of common feature that tips us off that some collection of test inputs all maps to the same bug. Then if we see another group of test inputs that contains some totally different feature, so maybe really deeply nested parentheses or really long identifiers, then it's a good bet that those map to a different bug. Now the problem is, looking over large randomly generated test cases is really painful. And so this is going to directly lead to our next topic, which is a really important one, which is test case reduction, or test case minimization. And that's an automated process for taking a large failure-inducing input and turning it into a small one. And we're going to cover that next.